Hi there, what is fatigue? Suppose we have a steel rod under static load, and as you know, the stress-strain curve of it will be schematically like this. It means if the static load is below the yield strength, then neither fracture nor plastic deformation will happen. And if only the load is a bit higher than yield strength, then the only plastic deformation will occur but no rupture. Now, suppose instead of the above static load, we apply a cyclic load on this rod. The cyclic load could be a repeated load or fluctuating load. For example, if we apply a load like this, and we change the direction of this load cyclically, compression, tension, tension for like thousands of cycles, and suppose the magnitude of this stress is smaller than the yield stress of this rod. By repeating this cyclic stress, even if it's smaller than the yield stress, a very tiny crack inside the material, which is so-called micro crack, can be generated, or the mentioned cyclic load could activate a micro crack which already exists inside the structure. So gradually, by continuing this cyclic load, the micro crack gets larger and larger inside the structure, and somewhere you should call it macro crack rather than micro crack because it has already become large. Finally, the macro crack propagates and somewhere the failure happens. Therefore, contrary to the static load, if you apply a cyclic load on a structure, it could fail, even if the applied stress is smaller than the yield strength of the structure. This phenomenon called fatigue. Now I have two important questions for you. Question 1. Which one is more dangerous, the static failure or the fatigue failure? If the structure is loaded statically and the load is larger than the yield stress, normally it will present a plastic deformation, and this plastic deformation is recognizable most of the time even with the naked eye. So, simply before happening the final failure, you get a warning from the structure, meaning that the structure has been overloaded. However, if you load the same structure by a cyclic load, a micro crack could initiate and propagate, and certainly with the naked eye you can't recognize what's going on inside material, so suddenly the failure happens. Therefore, the answer to this question is that fatigue failure is more dangerous than the static failure due to the fact that fatigue failure gives no warning and happens suddenly. Okay, we already understood how fatigue could be hazardous and how vital is to prevent unexpected fatigue failure by engineers. But the second question is there any way or ways to predict fatigue life? Fortunately, three main methods have been already introduced, or let's say estimate the fatigue life, namely the strain life method, the stress life method, and the linear elastic fracture mechanics method.